Okay, I'm in a very crowded room. I'm sitting at the edge and facing the wall, but it's still probably going to be fairly quiet, but you guys are using every not crowded room, so um, also I have children to watch. I just wanted to readdress the choice of delta. So because the rule is for blah 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 blah, there exists a delta so that when this is true, something else is true, right? This is the rule. So it says there exists a delta that does this job. So here's x. Well, there, okay. That's crazy looking. So if this is x plus delta, then that's x minus delta. And basically we're saying if x is in here, so I'm not even going to draw a graph with a function on it now, I'm just restricting my view here to the x's. So it says if x is in this interval, then something is true. So for our statement to be factual, we know it works in here for this every x in here, which means if I chose a smaller delta, this smaller delta, it actually is the case still that if x is in here, then this is true, because if x is in here, then it's in the whole big one. When you're going along and you're trying to choose delta, and you've got, like, here's your c. Oh, yeah. So here's your c, and you're saying, how far can I go? And on one direction you end up over there, and on one you end up over there. The reason you have to choose the smaller one is because you need to be able to go delta in either direction. You know that this is true if x is in here. But if I choose this as delta, then I come over here and I don't know anything about these guys. So for all I know, they could map to the moon. I don't know anything about them. All I know is if you're in this interval, then this is true. So this is where you've done the algebra and you end up with two bounds on x, and one of them's farther away. So what you do instead is choose the smaller delta, because now if I just go that little amount, that's in here. So if x lives in here, then it lives in there, then this is true. So that's why you always choose the smaller delta. So you can refer back to the previous video, but we ended up with something like, over here, let's suppose that I did the algebra. So I started out with the function minus whatever is less than whatever, and then I trapped it. Oh, good grief. You know I'm going to end up doing this anyway. So let's say x cubed minus 4. And let's say that I'm looking at the limit as x approaches 2. So then I try plugging in, and sure enough, that gives me a number. So this is what I want to try to show, right? So I want to say, given epsilon, find delta. Sorry, I had to help a learner. So given epsilon, you want to find delta so that okay, so it's 2. Okay, so this is where we have to get it outside the absolute value. And then we add 8. And then we take a cube root. Okay, so at this point, without a number being given, we're in a little bit of a mess. We could kind of try to figure out like the concavity and stuff, but that's getting ahead of ourselves to future calculus. So at the moment, we probably want to say, suppose epsilon is not greater than, epsilon is equal to 0.01. So now we have cube root of 7.99. Cube root 8.01. So I'm going to go here. Oh. And then I'm going to do 2 minus A1. Okay, those are very similar. I was hoping they'd be less similar. 0.00833368, 0.000833. So the point is that the distance each of these is from 2 is different. So if I were to draw the little circle, not circle, but open set around 2, I would go in the one direction up 0.00833, in the other direction 0.008338. If I were to go 0.00083368 to the right of 2, I would get values that I have no reason to believe make f of x minus 4 less than epsilon. But I can safely go 0.000833 to the left because I haven't gone as far as I'm allowed to go right here. So that's why I choose the smaller delta. It's sort of it's not exactly abstract, but it's kind of abstract, and that's why you guys are still a little uncertain about it. And I really didn't want to spend as long as I already have now on this part of it, because there's another thing that I wanted to point out to you. If you had, say, the limit as x goes to 2 of x squared minus 6x plus 1, so we would want that to be 4 minus 12 is minus 7. So then we say, okay, epsilon's bigger than 0. We want x squared minus 6x plus 1 minus negative 7 to be less than epsilon. And we're looking in the end for something that looks like this. So inside here we do x squared minus 6x plus 8. Okay, sorry, got distracted there. So inside here we factor. Whoops. So if I want to rewrite this in pieces, because I've got a piece here and here, this is what I'm trying to get. So I can rewrite this like this. And that's fine. My cursor. Okay, so remember my goal is to get this piece. So I would divide on both sides. like that. Now, at this point, since we're taking the limit as x approaches 2, I think you guys have just been going a whole on either direction. Okay, so I keep having to do my actual job, but okay, so you guys have been going from this to saying, okay, well then how about this? Now, you can choose this, you can choose 0 and 4, you could choose 1.00 or 1.999 and 2.001. It doesn't really matter, you just have to pick things that aren't 2, one below and one above. But because when I write this, I'm saying I'm choosing x to be no more than 1 away from 2, it's kind of a without loss of generality kind of thing, but we're not letting it be more than 1 away from 2. So we have to say, well, then delta has to be less than 1, because that keeps it in here. Okay, so we have to stay in there. If you chose instead to do this, then you'd have to say, note, delta cannot be more than 0.01. Okay, so we're limiting delta when we choose these bounds. Then the way you decide which one of these to use is by which one makes the smaller delta, because remember we have to pick the smallest. So either my options for delta are epsilon over 3 minus 4 in absolute values, or epsilon over 1 minus 4 in absolute values. So that's epsilon or epsilon over 3. So I choose the 3 because it makes it smaller. So when it's a denominator, you choose the one that makes the denominator the biggest. And when it's if it was in the numerator, you choose the one that makes the numerator the smallest. So this is how you pick which one of these guys to plug in. And you know, if I'd done it this way, then I would have chosen epsilon over 2.01 instead of epsilon over 1.99. Okay, so hopefully that's a little clarifying, and I'll try to clean up this video from all the stops and stuff real quick.